just looking at the coefficients, 10 and 5, what is the GCF of 10 and 5? Bo says, and he's wondering why no one else said it, right? Me too. Why did no one else say 5? 5 is correct. So both of those are divisible by 5. So we would take a 5 out in front. And then if they have a variable in common, which they do, you want to take out the smaller of the two exponents. So this is x to the second power. This is x to the first, right? So since that's the smaller of the two exponents, we're going to take out x to the first power, which we don't really need to write the first power. Now, I don't know if factoring was ever phrased to you in this way, but factoring is the opposite of distributing. You're undoing distribution. So moving forwards, if someone said to distribute, you would multiply 5x times what to get 10x squared, and 5x times what to get 5x. If distributing is multiplying, then factoring is dividing. Write that at the top. If distribute means multiply, then factor means divide. So we are deciding, instead of multiplying the 5x through, we are actually dividing the 5x out. So term by term, if I divide out a 5x, and I'm just going to write that very lightly, the 10 divided by 5 gives you 2. And then here come your exponent rules. X squared divided by x to the first. What's the rule with common bases? What do I do with those exponents? Subtract. So that leaves you x to the first power technically. Yes? And then if I divide 5x out of there, well, now it's just anything divided by itself is 1. So plus 1. And there we are, factored. Okay? Now you can factor with 2 terms, 3 terms, 4 terms, 5 terms, 6 terms, dot, 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 goes on forever. So now here we have 3 terms, and we're going to take it number by number, variable by variable. So look at your coefficients. -8, -12, and 2. What's the GCF of those, Cameron? 2. He's correct. There's one general rule I'm going to throw at you. If your polynomial starts with a negative sign, we want to factor that negative out as well. If it leads with a negative, we're going to not just take out a 2, we're going to take out a -2. Okay? Now, next variable, x. Kaylee McCadden, can I take out an x, and if so, x to what power? X to the second, because we have an exponent of 3, a 2, and a 9. The smaller of all of those is x to the second. And then Grace, can I take out a y? If so, to what power? Y to the third. Now, the polynomial started with 3 terms. So when I divide out this GCF, I'm going to be left with 3 terms in my parentheses as well. And take it piece by piece. Do not rush through this. If I'm dividing out -2x squared y cubed, what do you think is left? Jordan. That's it. That's all I want. Just the first term out of you. Perfect. +4x y squared. So you divide your coefficients normally, and your exponent rules come into play with your variables. Good? What's going to be left? Take a second to think about it when I divide this out of the next term. Jake. 6y to the fourth. What sign? plus. Good. 6y to the fourth. The x squared's just canceled, right? It's technically x to the 0 power. But what do we know? Everything to the 0 power is just? No. 1. And so you don't really need to see it. 6 times 1 would just still be 6. And then y to the fourth. Think about your last term. And what do you think, Nathan H? Negative x to the 7th. Anybody think anything different? Perfect. The negative comes from positive 2 divided by negative 2. If you put 1x to the 7th, that's still fine. And there your y's canceled. Okay? Yeah. It does. As opposed to what? So, and that's the general rule that I was just talking about. 90% of the time, if it leads with a negative, and there's a reason that we'll get into when we do more advanced factoring that we have to do this. If it leads with a negative, you got to factor it out. That's our rule. Now there may be, 1 out of every 20 times where if it's a multiple choice, maybe they do not take that negative out, and that's a positive, so this is negative, negative, positive. That's what you're saying? There could be a moment like that where your multiple choice, that's the solution they provide, but 19 out of 20 times not. They're going to, if it leads with a negative, they're going to take out a negative. Nathan, did I make a mistake?
No, I was just going to ask.
Oh.
If it began as 8x to the third, y to the fifth, then
you wouldn't have taken out the negative.
Right.
Correct. Because we don't want polynomials to lead with a negative term. That's the reason. And you'll see maybe it's tomorrow that we get to kind of why that happens. Okay? All right, good questions. Now this one looks a little funny, yeah? Because it kind of looks already factored, doesn't it? I'm certain that a lot of your gut right now is telling you to start distributing, which would be a big no-no. Because remember, distributing is doing the opposite of what these directions are telling you to do. Directions are saying to factor. So you wouldn't want to distribute. We're trying to look at this and decide what is the GCF. Now, part of the issue is, what is this thing? Is it, how many terms are there in this polynomial? What'd you say, Cameron? 2, and he's correct. It's hard because your terms, there's your first term, and there's your second term. Your terms of your overall polynomial contain polynomials in and of themselves, which is why it's visually a little bit confusing. But you want to see this as 2 terms. It's this plus this. 2 terms. What do they have in common? What do they both have? X minus 7. They both have an x minus 7. That's my GCF. So your GCF here was a monomial. Your GCF here was a monomial. It's a long monomial, but that's still 1 term. Your GCF here is actually this binomial. They both have this binomial in common. So we're going to bring that x minus 7 out in front. And because it's a binomial, we're going to keep it in parentheses. Now when I divide the x minus 7 out of the first term, what's left? Just the 2x. When I divide the x minus 7 out of the next term, what's left? Plus 3. That's it. X minus 7, 2x plus 3. Yep.
Well, how do you decide to use x minus 7?
Because if I look at them, that's this particular term has 3 factors, a 2, an x, and an x minus 7. This particular term has 2 factors, a 3 and an x minus 7. So what factor did they both have? X minus 7. So I took that out in front. And when I divided that factor out, this was left with a 2x, this was left with a 3. You almost just have to train your brain to see that commonality between the two terms, to see that x minus 7. And we will do a lot more like this, again, wrapped up in a skill that's coming tomorrow, where it will seem easier. The first time you see it, it's a little bit odd. Okay, try this next exercise on your own. Mason, what'd you get?
5xy parentheses ax minus 2.
Did anybody get anything different? Okay, good. 5 and 10 has a 5. If you look at your x's, you take an x out. Who? Madeline. Okay, at the end of the period. I'll give you a pass. If I take out a 5x, and then they have both a y in common, again, it helps. The more complicated they get, the more numbers that are wrapped up in it, the more helpful this showing the division is. 5 divided by 5 is gone. The a is still there. X squared divided by x is x. Y's are gone. And then over here, divided by 5xy, negative 10 divided by 5, negative 2. X's cancel, y's cancel. Perfect. Okay? In these easier examples up here, the simpler ones that don't have multiple variables floating around, you may not find that necessary. You actually might find it more confusing. It depends on your skill level. For some people, it helps all the time to see you divide out that GCF term by term. Do the last two on your own. Okay, thank you. Raise your hand if you're done with both. Okay, I'll give you 30 more seconds for those of you still finishing up. All right. Kirsten, what'd you get for the first one? I just took your 1 out, just because I think most people probably wouldn't write it. Did anybody get anything different? Let me just look. They got a 7 in common, a D in common, an E. 7DE leaves CD, and 7DE leaves minus 2. Perfect. And the second one, what did you get? Jordan. Just like that? Raise your hand if you got something different. Uh-oh. Tell me, Kaylee Smith. Plus 1. So, Jordan, when you divide out that 3x squared, here's, again, that general rule I was talking about, and I said it earlier. If your polynomial starts with 2 terms, even though you're taking something out, you should still have 2 terms always, right? Because remember, when you distribute, you should get back to the original if you want to check it real fast. But right now, Jordan, 3x squared times 5x only gives us 15x cubed. Where would that ever come from, right? And the idea is you divided that 3x squared away from both terms. So when you divide it away from the last one, anything divided by itself is 1. Now if you check to redistribute through, you'll still get the 2 terms. Does that make sense? Good job. Okay. flip over to the back and write 4 terms at the top. This may be where we're a little different than what you did last year. So write down x cubed minus 3x squared plus 4x minus 12. Do you see any GCF of all 4 terms? Anything that can be divided out of all 4? Should be a no, right? So there is no GCF. So once we get past this GCF stage, we're going to look at a couple different scenarios. 4 terms, 4-term polynomials, 3-term polynomials, and 2-term polynomials. And we're going through it in that order, and it seems weird. Why would we start with the highest number of terms first and move down? There's a reason. So if I don't have a GCF, and you see 4 terms, there's a method called grouping. Raise your hand if you remember this, grouping, or have heard of it before. Not many of you, just one from what I'm seeing. So I don't know if you did this in Algebra 1 or not, but here's how grouping works. If you have 4 terms, you group the first 2 terms, and you group the second 2 terms. And mind you, I'm keeping that plus sign with the second 2 terms. And you really kind of process the GCF idea twice. So look at your first 2 terms. Do those have a GCF? Is there a GCF of just the first group? Yeah, what can I take out of that? X squared. And when I take out an x squared, there's my parentheses, what's left? X minus 3, very good. So out of my first group, I can have a GCF. Look at your second group now. Does that have a GCF? What is it? Positive 4 or negative 4? Positive. So bring that positive out with it. Positive 4. When I take that out in front, what's left? X minus 3. Now grouping isn't always effective. Here's how we know that it is. Do you see how they both have the x minus 3 in common? I'm going to remember this example from the front, how weird that looked, Andrew? This is why we did this type of example, okay? Because this is part of this grouping process. Those had an x minus 7 in common. We then pulled it out in front. So now if we look at this as just 2 terms, here's your first term, here's your second. What do they have in common? X minus 3, right? So I'm going to pull that x minus 3 out in front, and what's left of the first term? What's left of this once I divide out an x minus 3? Just the x squared. And what's left of this one once I divide out the x minus 3? Just the plus 4. And I'm done. That's how you factor a 4-term polynomial. It's kind of a mini GCF process twice, and then one last GCF process to get you there. Nathan? You would, because if I didn't, if I just had this, that would be like only wanting to multiply the 3 through, and it wouldn't turn out to be like the original. So if your GCF is a binomial or any polynomial at all, you take it out in front and keep it in parentheses, because now if I wanted to check it, what's x times x squared? X cubed. What's x times 4? 4x. What's negative 3 times x squared? And what's negative 3 times 4? Okay? We have time for one more. Write this down. X to the third plus 6x squared minus 2x minus 12. No GCF, right? So group the first 2. What's the GCF of just the first 2? X squared. What's left in parentheses? X plus 6. Very good. Group the second two. Micah, this is going to be the reason for the negative, you'll see here. What's the GCF of negative 2x minus 12? Negative 2. It leads with a negative, so now if I take out that negative 2, we have x. What's negative 12 when you divide out a negative 2? Plus 6. And what now has happened, which would not have otherwise, is these two now match. If you hadn't taken out the negative, they wouldn't match, and then grouping would have looked like it was a bust. So now they have x plus 6 in common that I bring out in front, and what's left? Very nice. So your homework is actually this. It says 1 through 10 all. It's 1 through 16 all on a worksheet that I'm about to hand out. So change that. Here's the thing though. We already did 12 and 14. Those were 12 and 14. Okay? This worksheet, you're definitely not doing it on the worksheet because your homework over the next 3 or 4 nights is going to come from this worksheet. So make sure you're doing it on a separate sheet of paper. Also, so we're doing 1 through 16, and which two numbers did we already do? 12 and 14, so you do not need to redo those. I'm handing out an 11 problem packet to help you just familiarize yourself with what's on the test tomorrow. I will send a remind message with pictures of the solutions and all the work. So you can more or less use this to study and just know what's on the quiz tomorrow. Yeah.
Packet and then sheet tomorrow.
The packet I'm not going to collect. It's for your own benefit to study for the quiz tomorrow. Because I'm going to hand out the solutions and all the work. Or I'm going to text it to you all. So if you don't have the Remind app via your phone, check your email if you want access to it. That's going to your email. Any questions?